Okay, hi everyone. So now I'm here with the stoichiometry videos that I told you I would do for you. So this is going to be the first one, and this one's just going to be a regular stoichiometry problem where we have a balanced chemical equation as shown. Right? So we have methanol combustion reaction. Right? So this first question says we want to calculate the amount of oxygen needed to react with 1.7 times 10 to the third grams of methanol. Okay, so we're given that we have 1.7 times 10 to the third grams of methanol, right? And we want grams of oxygen, right? So we're only looking at two things here. We're just looking at methanol and oxygen. So that's all we care about. So we're going to ignore the carbon dioxide and the water. Right? So just worried about methanol and oxygen. Right? So remember, when we're doing stoichiometry, we're following a path, right? We're going from grams of the given, in this case is methanol. All right? We're going to change it to moles of given, which is still methanol, right? And then we're going to go from moles of given to moles of wanted. In this case, the wanted is oxygen. And then we're going to go all the way to grams of oxygen. All right? So grams of the given to moles of given, and then moles of given to moles of wanted, and then moles of wanted back to grams of wanted. All right? Okay, so that's our mass to mass conversions for stoichiometry. All right, so let's start with our given. Actually, let's start per expressions first. All right? So our per expressions are going to be what takes us first from grams to moles, right? And remember, that's going to be molar mass. So convert your grams to moles using molar mass for methanol, right? Okay, and so the molar mass of methanol is 32.042 grams of methanol per mole of methanol. Okay. So now that's taking us from grams of methanol to moles of methanol. And then from moles of methanol to moles of oxygen, we need our mole to mole ratio. Right? So moles of methanol, right? The coefficient is 1 there, right? And the coefficient for oxygen is 3. So that's 3 moles of oxygen for every 1 mole of methanol. Right? And then from moles of oxygen to grams of oxygen using the molar mass of oxygen. So that's 31.998 grams of oxygen per mole of oxygen. All right. So now we have our 3 per expressions ready. See, 3 steps. So 3 per expressions. And so we can go ahead and do our setup, starting with our given. 1.7 times 10 to the third grams of methanol. Convert to moles using molar mass of methanol. So for every 1 mole of methanol up top, we need 32.042 grams of methanol on the bottom, so that grams of methanol can cancel. All right? And then from moles of methanol to moles of oxygen using the mole to mole ratio, 3 moles of oxygen goes up top, so that moles of methanol will go on the bottom. All right? Moles of methanol cancel. And then lastly, right, the molar mass of oxygen, 31.998 grams of oxygen per mole of oxygen, so that moles of oxygen can cancel. Right? Then, right, we take our 1.7 times 10 to the third divided by 32.042 times 3 times 31.998, and we get 2.5 times 10 to the third grams of oxygen. All right, 2 sig figs because there were 2 sig figs here. Okay. All right, so like I was saying, that's a standard stoichiometry problem. And actually, we're going to do, so this was part A. We're going to do one more. All right, one more. But we're going to stick with the same balanced equation here. All right. So real fast though, just so you can see, you don't always have to go from reactant to product. In this case, I'm just looking at two reactants here. Right? Right. So with this next one, right, this next one says, how much water is produced in grams when 121 grams of oxygen react with an excess of methanol? So this time we're looking at our given, right, as the 121 grams of oxygen, and our wanted as our grams of water. All right, so this time we're looking at oxygen and water. All right, so this time we don't care about methanol and carbon dioxide. In fact, it's telling us we have an excess of methanol, so we don't even have to worry about it. All right, that means we have plenty of it. All right. Okay, so our per expressions here, right, are going to be right, molar mass of our given, which is oxygen, right, 31.998 grams of oxygen per mole of oxygen, right, and then our mole to mole ratio, right, between these two, right, so we have 3 moles of oxygen, 4 moles of water, right, 3 moles of oxygen over 4 moles of water, right, and then our molar mass of our wanted, which is the water there, so that's 18.015 grams of water per mole of water. Right. Okay, so our setup, 121 grams of oxygen, right? Molar mass, so 1 mole of oxygen over 31.998 grams of oxygen. Right, grams of oxygen cancel. Times, right, the mole to mole ratio. We're going to put the oxygen on the bottom, so 4 moles of water up top and 3 moles of oxygen on the bottom. Moles of oxygen cancel. Times the molar mass of water, 18.015 grams of water up top per mole of water on the bottom. Moles of water cancel. Right? And so the grams of water that's produced here would be 90.8 grams. Okay? All right. And so again, those two problems were your regular stoichiometry problem, right? And so the next video I'm going to do a limiting reactant problem, right? And then I'm also going to do another video with a thermochemical stoichiometry. Okay. Already stopped it?